Okay, so welcome again. So we had already completed the previous part over here. So totally the problem was for 14 marks, and since my light was getting heated and I didn't have much of time in my video recording session, I thought let me split this video into two parts. Okay, so out of 14 marks, we have already completed 2 plus 3, 5, 5 plus 3, 8 marks. So which means we are really going online, right? Okay, good one. So 8 marks in 8 minutes, we already done with this. 6 marks, 7 minutes also we have done, right? 1 minute we have more. Now we the rest 6 marks we are going to do here. Okay, let us start. The initial kinetic energy of the alpha particle is 4.3 million electron volt. Let me write kinetic energy initial. As the alpha particle passes through air, it loses all its kinetic energy by causing an ionization of 1.7 into 10 to the power of 5 air molecules. There are so many air molecules over here. So this giant alpha particle, when it goes, what does it do? It ionizes all of them. It knocks off an electron from here, it ionizes them. So state what is meant by ionization. What do you mean by ionization? Ionization means it is removal of an electron from an atom. Okay, this is what you got as an ionization or a molecule. You can write anything over here. Okay, so therefore 1 mark is got. Then estimate in joules the average energy needed to ionize an air molecule. So what do we write here? What is the average energy needed to need an air molecule? Now you see, when you have 4.9 million electron volt, it can ionize 1.7 into 10 to the power of 5 air molecules, right? So therefore, so I will write like this: to ionize 1.7 into 10 to the power of 5 molecules, you needed an energy of 4.9 million electron volt. So you are asking in terms of joules over here. Okay, 4.9 million electron volt. Therefore, if you want to ionize an air molecule, if you want one molecule, if I want to ionize, what do I need? I need to find 4.9 million electron volt divided by 1.7 into 10 to the power of 5. But I want in joules, so I will convert this over here and write this as 4.9 into million, 10 power 6 into E, 1.6 into 10 to the power of minus 19 divided by 1.7 into 10 to the power of plus 5. Let us use my calculator, find out what is the value. This is my calculator. It's here. So I will use 4.9 or 1.6 divided by 1.7. So how much do I get? I get 4.6 here. 4.61 into 10 to the power of, here you have 6. Here are minus 19. 6 minus 19 should be minus 13. Minus 13, when this goes away, this should be minus 13 minus 5. This should be minus 18 joules. What is the answer I get? It's a correct answer, 4.61 into 10 power minus 18 joules. Okay, so this is given for 2 marks. How do we get 2 marks? The first 1 mark comes for this logical understanding. Second 1 mark goes for the correct conversion and getting the final answer. Right. Now let us move on to the next one. Outline why a beta particle has a longer range in air than an alpha particle of the same energy. So why does it happen? So to answer this, the first one is, what is a beta particle? Beta particle, for 3 marks over here. Beta particle is an electron, right? And if it is an electron, you are comparing electron with an alpha particle, which means what? How do you compare over here? Based on charge, you can compare, because this has a negative charge, this has a positive charge, that you can do it. And secondly, you can see the mass of an electron is much lesser than the mass of an alpha particle, right? So as a result of this, if I give the same amount of force for an alpha particle and that of a single marble, which one will go farther? You can see the marble will go farther, right? So therefore, this is the first point that you need to make, and then you say, okay, it has a longer range in air than alpha particle because, so because of this, V electron would be far greater than V alpha. Okay, so therefore you get this one here. And secondly, beta particles have less charge, right? If it has less charge, what will happen? So it will not start interacting with every particle. It is just an electron, right? An electron cannot knock off everything. So as a result of it, less interactions as compared to alpha particle. So what can happen? It can easily pass through larger distance, right? It can easily pass through a larger distance. So this is also possible. So this is one more reason. So one more answer here. So finally, you have to conclude. What is the conclusion? So because of these two, range for beta particle is higher than alpha particles, right? So you get automatically all the 3 marks over here. Okay. So hope this is useful. Okay. So we are able to complete it within that time, right? So thus we have seen that all the problems we are able to complete it within the simulated amount of time. Of course, I have worked out all the problems, but I try to explain it also in the same manner. Okay. So this much amount of knowledge should be present in your system, in your head, so that you will be able to solve the problems at this pace. Okay. If you start thinking each and everything and say, "Arey, how to write this one, what to write this one," and so on, in the exam hall, you will not be able to get it. Okay. See, the concepts are much clearer over here. I did not assume anything over here. Okay. Whatever has been taught in the class, the same thing I put it across, and this is how you need to proceed also. Okay. Thank you. Have a nice weekend, and next week we'll see more number of problems. Good day.